algebra, we are moving on to PO28, the first of two objectives to close out our unit. And both objectives are on parallel and perpendicular lines. Okay? We've talked about linear functions for a while. We've talked about slope and form. We've talked about graphing them. Today we're going to bring in those special types, parallel and perpendicular. So first of all, what does it mean for lines to be parallel? Whoa! Boy, oh boy. What does it mean for lines to be parallel? Lucas.
If they want, since lines go on forever, they will never intersect.
Okay, parallel lines are lines that will never intersect. If you graph them on the coordinate plane, they will never, ever, ever cross. Okay? And so the question that arises here is why? Why won't the lines ever cross? What makes lines parallel, and why does that explain why they will never intersect? Henry?
Because if you, let's just say a rectangle, if you take the top and bottom one, if they just keep on going on, they're two straight lines that are, they're equal to each other, and so they'll never touch. If they were angled, they would actually intersect.
Okay, but mathematically, what determines, or what makes those parallel lines, what ensures they'll never intersect, they'll never get closer together, right? Because if two lines are getting closer together on the corner plane, eventually they will cross. Parallel lines don't. They stay the same distance apart from each other. Okay, Kaylin? They have the same slope. Okay, boys, you hear that in the back? That's kind of the key here. Okay, parallel lines have the same slope. Think of your best friend. You might know how many days older or younger you are than that person. Will you ever, the two of you, ever get closer in age?
No.
No, because you're aging at the same rate, right? You're all aging at 1 second per second. You're never going to catch up, right? And parallel lines are kind of similar. And that, remember, slope determines how a line moves across the coordinate plane. Kyle, if two lines are moving across the coordinate plane at the same rate, Matthew, turn around please, they're never going to get close to each other. They're never going to cross. So two lines that are parallel will have the same slope. They are moving at the same rate. They are not getting closer together. Because lines that do get closer together will eventually cross. These will not. Okay? So, for example, if line A has a slope of 7/2, a line that is parallel to it will have a slope of 7/2, right? They're both moving at a rate of up 7/2. They're never going to cross. Okay? Similarly, if line A has a slope of -3, down 3/1, down 3/1, down 3/1, a line that's parallel to it will have a slope of -3, down 3/1, down 3/1, down 3/1. Okay? So parallel lines have the same slope, but they would have to have a different y-intercept, right? They would have to cross the y-axis at different spots, but they're moving at the same rate. Hey?
You got a bandana, please?
I do.
I feel like they did this on purpose.
Did you watch the football game last night?
You know the mini
On my computer, yes.
You got like a minion one?
A minion one? I don't think I do. I got like regular, I got pink, I got
Oh, let me get this one right here.
the space one.
Yeah.
Okay.
Oh, yeah, Peyton. You know the grass salad.
Okay. Come on back. Shh. Okay. So parallel lines have the same slope, they move at the same rate. Okay. Tell me what you know about perpendicular lines. Dominic, Ron. Tell me what you know about perpendicular lines. Claire.
Won't they like only cross once?
All lines only cross once,
Oh.
right? Because they can't curve around and cross it a second time. So perpendicular lines do intersect, but they intersect in a special way. Dominic? An X shape. Give you a little more.
Are all sides like 90 degrees?
Okay, so it has to do with 90 degrees. They intersect at a 90-degree angle. Okay? If you think about two lines that just intersect, right, that's kind of an X shape. Okay? But they are not at 90-degree angles. Two lines that intersect at a 90-degree angle, for example, your coordinate plane, your X and Y axis, that's a right angle. They are perpendicular lines. They can also intersect in more of an X shape like I think you were referring to, okay? But they intersect at a 90-degree angle. Intersect at a 90-degree angle. And again, it all has to do with slope, okay? What would the relationship of slopes be between perpendicular lines that would cause them to intersect at that specific type of angle? James? Opposites, okay? So if line A has a slope of, we'll use 7/2 again, okay? What would the opposite slope be of 7/2 that would cause it to be perpendicular? Gabe?
-7/2.
Not -7/2. Lucas?
The reciprocal to sevens.
Put those two things together. Negative reciprocals. Okay? Two lines that are perpendicular will have negative reciprocal. I'm writing nice and neat so you know how to spell it. Negative reciprocal slopes. Which negative means opposite sign. Reciprocal means it's flipped. So a line that has a slope of 7/2, one that's perpendicular to it will have a slope of -2/7. -2/7. The sign is opposite and the fraction is flipped. So if line A has a slope of, we'll use -3 again here. What is the negative reciprocal of -3, Jude?
1/3.
Positive 1/3, right. Your sign is the opposite, so it's positive. And since -3 is like 3/1, the reciprocal of that would be 1/3. Okay? So, perpendicular lines are a little bit more complicated than parallel lines. Parallel lines just the same. Okay? Perpendicular, it's that negative reciprocality. Right? Negative reciprocals. Questions on any of this? No? Okay. So the rest of PO28, what I believe is a one-pager, is it?
Two.
Not? Two? Ooh, boy. Is basically determining if line A and B are parallel, are they perpendicular, or neither. So for parallel, we're looking for same slope, right? For perpendicular, we're looking at negative reciprocal slopes, and anything else is neither. Meaning they're not parallel, they're not perpendicular, they will intersect, but it's not in a special way. You know, if they're not negative reciprocal, they might look like that, or they might look like that, right? They intersect, just not at a 90-degree angle, okay? So, first one, line A has a slope of 4x plus 3. Line B is y equals -4x plus 7. We only care about the slopes. Are those slopes the same?
No.
No. Are they negative reciprocals?
No.
No. So this one would be neither. These lines will intersect, but not in a perpendicular way. Okay? Next one. Again, only care about the slopes. 2/3 and 2/3. Are they the same?
Yeah.
Yes. What does that mean? Parallelity exists. Okay, they are parallel. The last one we already kind of talked about in the example. Again, only caring about those slopes, -3 and positive 1/3. What's the relationship? Perpendicular. Lazy bums.
You're not gonna be able to. If I write perpendicular, I'm not gonna be able to read it. So
Well, not my notes anyway, so.
Are we lazy or
on the
did we do
test.
our tests last time?
I grade on the weekends, and I forgot them at home. That was forgetfulness, not laziness.
Why you spelled that?
You could have tripped his voice.
So, the nice part about PO28 is that it allows me to bring back a whole bunch of other concepts, Will, Jude, from previous objectives, mainly from the last test. A number of you need to retake PO22. That was one where we converted from standard form to slope intercept form. Look what you gotta do now. I tell you line A is 4x minus 2y equals 12. Line B is negative 8x plus 4y equals negative 4. What form are those equations written in? Standard. Does standard form tell you what the slope is? No. So you have to practice converting to slope-intercept form to determine what the slope is. So for example, line A. Our equation is 4x minus 2y equals 12. And this is why we have the POs. Right? In life, not in math, not everything is going to be presented to you in the best, easiest way. You do need to understand how you can manipulate equations, rewrite things, get it to what you want it to be, so you can make your determination. So, yes, when you manipulate, you change, right? You affect. That's what we're doing here. So starting by subtracting negative 4x, or by subtracting 4x, we get negative 2y equals negative 4x plus 12. Divide both sides by negative 2. And we get y equals positive 2x minus 6. We don't really care about the minus 6, but whatever. Okay? So the slope of line A is 2. Right? That's what we care about. The slope of line A is 2. Line B, negative 8x plus 4y equals negative 4. Start by adding 8x to both sides. 4y equals positive 8x minus 4. Divide everything by 4. And y equals 2x minus 1. Again, we care about the slope, which is 2.
Girl,
What does...
that was way too fast.
Yeah, no.
Well, we've done this before.
I
This is
looked down, I
22,
looked
like,
down for 1 second.
Too fast for me, little girl.
I feel bad.
We've done this before. If you-
Yeah, and I failed it miserably.
Well, this is good practice, I guess, then.
Do we have to
Okay?
write all that out?
Go ahead, watch the video, put it on 0.5 speed. It'll be nice and
Easy.
slow.
Hurry up. Can you go faster?
Okay,
Double speed.
Okay.
So,
Double speed, double speed.
what do we know? What is the relationship between line A and line B, Grace? They are parallel.
I want 2x speed.
They are parallel. Okay, so for these first three, you are converting to slope-intercept form. If you need the steps for that, look back at PO28. Basically, you're moving the x term over,
Don't erase that.
divide by the coefficient to y. Those are your two steps. Move the x term over using opposite operations, divide by the coefficient to y.
Where does the back page?
Okay. The second page, I give you 2 ordered pairs from line A and 2 ordered pairs from line B. How are you going to calculate the slope?
You do y1 minus y2.
The slope formula, PO20, y2 minus y1 over x2 minus x1, right? Again, not a quinky dink, that is a PO that you need to go back to get this. I did say quinky dink. Yes, indeedy.
Yes,
Okay.
indeed.
Yes, indeed.
What about the bottom?
Okay. The 2 brain busters at the bottom. Says, write the equations of 2 parallel lines in slope-intercept form. Give me the equation of a line in slope-intercept form. Damien.
I was just asking, can I go to bed?
Sure. Give me the equation of a line in slope-intercept form. James?
Y equals 2/3 plus 4.
2/3 x
2/3, yeah.
plus 4. Okay. And so now line B, it has to have the same slope. Y equals 2/3 x, we'll say,
Eight.
plus 8. Sure. Okay. The y-intercept would have to be different, otherwise it'd be the same line. Okay. If the equation is exactly the same, then it's a line on top of itself. That's not parallel. Okay. And so now it says convert the equations to standard form. So if we take our first one, y equals 2/3 x plus 4. You need to convert that to standard form. James, being the always striving for greatness scholar that he is, even gave us a fraction to work with here. going to standard form. Because remember, standard form can't have fractions, right? So how do you undo a fraction? Give us a good chance to review this. How do you undo a fraction, Fiona? Multiply everything by the denominator, right? Again, back to PO22. Then,
You're welcome.
no, I'm glad you did. It gives us a chance to talk about it. Then the second one says write the equations of two perpendicular lines in slope and form. So same idea, only make them perpendicular lines, that negative reciprocal slope, and then convert those to standard form. Okay? So you don't have to use these equations. If you want to avoid the fraction, you certainly can. You can't avoid the fraction with perpendicular, because even if you start with an integer, when you do the reciprocal, it makes it a fraction. So at some point, you have to multiply by a denominator to put it in standard form. But you can avoid that fraction
No, I could put
with
this 3
parallel
over
lines.
3.
What's that?
I could put it as 1 over 1.
Yeah, don't be lame. That's lame. Don't be lame.
Wait, would we
Lucas.
also multiply the 2 by 3?
Don't be lame. What's that?
Would we also multiply the 3 and the 2?
Yes, but it cancels it out, right? When you multiply this by 3, you get 3y equals 6 over 3, which is just 2, right? It cancels out the denominator, and then plus 12. And then you move that 2x over.
And then it would be
Negative 2x plus 3y. Right? And then there is a review section down at the bottom as well. Okay, and all of this is due on Monday. Are there any you'd like to go over in more detail? Gabe,
The second one.
on the first page or the second page? This one? Okay, Gabe, give me an equation in slope intercept form.
Can we just use James's?
You want to keep the same one? Sure. So if we start with line A, y equals 2/3 x plus 4, what will the slope of a perpendicular line be?
it would be the same.
Not the same, parallel is the same.
Oh, wait.
Perpendicular,
Y equals negative.
and then after that,
Negative 3 over 2.
negative 3 over 2, right? So then your line B would be y equals negative 3 over 2x, and you can pick whatever one if you want. You can keep the same one, because the slope isn't the same, right? We'll just do plus, I don't know, 5, sure. And then you're converting both of those into standard form in the one below.
Oh, so I convert both of them?
Convert both of them, yes. Now convert the equations in standard form.
And then for the one right above, do I have to convert both of them to standard form too?
Yes. Yep. Which we're almost done here. Because of the fraction, we're going to multiply by 3 first. Our last step is to move that 2x over using opposite operations. So your final answer for this one would be negative 2x plus 3y equals 12. You move that 2x over to the other side. The sign has to change. Okay. Again, this whole thing here, converting to standard form, PO22 is where you want to look at for that if you need the steps. And that's when the lesson was taught. Okay. And for those that need to retake PO22, this is a good report. Other questions? Others you want to go over, I should say. Yeah.
Oh, okay, I didn't even realize he called them, at the very top of the page, problem number 3.
This one?
Yup.
Okay. So given two ordered pairs for line A, we're doing our y1 or y2 minus y1, negative 10 minus negative 4, over negative 3 minus negative 7. And negative 10 minus negative 4, negative 10 plus 4, negative 6. And negative 3 minus negative 7, negative 3 plus 7 is positive 4. Okay? Line B, again, y2 minus y1, 22 minus 30,
Negative 8.
over 3 minus 15. 22 minus 30 is negative 8.
Negative 12.
Sorry. If you need more help with this is PO20, where we have the slope formula there.
Oh, right.
And 3 minus 15 is negative 12.
Oh, I got these.
So what is the relationship?
Perpendicular.
Parallel, perpendicular, or neither?
Perpendicular.
No. Oh, yes.
It's perpendicular.
It
If you convert them both down,
Okay.
it'd be negative
Yeah,
over
the
2.
trap that folks fall into with this is they forget to simplify. Looking at these fractions as they are, -6/4 and -8 over -12, it seems like they're completely different. It seems like it'd be a neither for sure because they're definitely not the same. The numbers are all different. And negative reciprocals, I don't see any of that going on either. However, when you simplify, -6 over 4 becomes -3 over 2. And when you simplify -8 over -12, it becomes, Addie?
-4 over -5. Wait, no, wait, what? Oh, wait, I got the wrong, I accidentally put down 10 instead of that.
Okay?
-4 over -6.
Go further.
-2 over negative.
Go further.
2 over 3.
A negative divided by a negative is a
A
positive.
negative.
Okay? So, many of you said it, and you were absolutely correct. When you simplify these fractions, you see -3/2 and +2/3 are negative reciprocals. Therefore, the lines are perpendicular. But you have to simplify slopes.
My brain.
For those who've always asked, do we have to simplify? Yes, and this is the reason why. Okay, it's easy to miss a relationship if you don't simplify things. Okay? So, the key, parallel lines, same slope. Perpendicular lines, negative reciprocals. That's what you are looking for here, right? It also brings back PO28, practicing converting between slope intercept and standard form. Also brings back PO20, okay, with finding slope using a formula. Lots of POs going on here. Before we end for the day, a note. Yesterday I picked up 2 snack wrappers for people that were eating snack in here. If you do bring a snack, please take care of your own garbage. One was back over in that area. I think it was a pirate booty, something or other. I'm not quite sure. But one of them still had food. One of them still had food in it, which means that if that food falls out, it gets stepped on, chips turn to crumbs, things get kicked around. It makes it very, very messy. So if you bring Ziploc bags, you bring wrappers from crackers or chip bags or whatever it is, please take care of your own stuff. Okay? Secondly, 7BK was in here yesterday for indoor recess. When I came in for my class after lunch, there were 3 chairs that were tipped over. There were several tables that were all kind of wonky, and there were just chairs scattered around the room. Please take care of your seats. If you bring a chair, if you move a chair from one spot to the other, bring it back. If a chair falls over, pick it up, okay? Please don't leave your classrooms, because they're mine, it's also yours. Don't leave your classrooms a mess. Okay? All right, anything else with PO28? It is due on Monday. New con has been assigned as well. That is how you math.
Don't forget to like and subscribe.
Thank you
Take that.
very much. Because we've got